Proportions and similar figures. A proportion is an equation of the form A over B equals C over D. So for example, 1 over 2 is equivalent to 5 over 10. They are both equal, but they're written a little different. 1 over 2 is simplified, but they're equivalent. So we use proportions when values to find values where different variables have to be kept in relative amounts for each other. And a really common example of this is cooking. So rice requires 2 cups of water for every 1 cup of rice. So a common question would be, well, let's say you don't want to make 1 cup of rice, you want to make 3 cups of rice. Well, so the amount of rice to water has to remain equal. But you want to make more rice, you're going to need more water. So let's say you make 3 cups of rice instead. How much water do you need? Well, you can probably see that we're multiplying by 3 to get to the amount of rice we want, which means we're also going to have to multiply the amount of water by 3, which would be 6 cups of water. And you can do this many different ways, but what you can see is that when we have various variables involved, this is actually a rational equation because you have 2 fractions and we're probably going to have some variables involved around here. This is a more simple example of this type of problem, but the idea is the same. When you have certain numbers that have to be kept in proportion to one another, and then you want to change one number, you're going to have to find that other variable. Here's an example. When pediatricians prescribed acetaminophen, which is, I believe, the main ingredient in Tylenol, so it's just a common pain reliever, when they prescribe it to a child, they prescribe 5 milliliters of acetaminophen, I hope I'm saying that right, acetaminophen, for every 25 pounds of the child's weight. So the bigger the kid, the more of this drug they're going to require for their pain medication. So if Zoe weighs 80 pounds, how many milliliters of acetaminophen will her doctor prescribe? So let's go about setting up this equation and solving it as a rational equation. So the proportion that we have to keep in amount is going to be the milliliters for a certain number of pounds. So milliliters over pounds, LBS for pounds. That's what we have to keep in proportion. And so for children, we're told that we require 5 milliliters for every 25 pounds of the child's weight. Now, if the doctor is needing to know how much to prescribe to an 80-pound child, well, then we're going to say that that's equal to an unknown, what I'll call X, number of milliliters of the drug, acetaminophen, to 80 pounds, the weight. And now I have a rational equation that I can solve. So I'm going to rewrite it without the units. 5 over 25 equals x over 80. And now you can use any method that you like to solve this. For many of our rational equations, we would multiply by the number that would eliminate the denominator completely. So we could take that tactic. Another option is just to isolate the x on the right-hand side. If we multiply each side by 80, then we cancel the 80s on that side and we're left with x. And now I have 80 times 5 over 25. So 80 times 5 over 25. And I'll have to do this in my calculator. 80 times 5 is 400. So it's 400 over 25, which comes out to 16 is equal to x. So when answering word problems, make sure to reference the word problem. So you don't have to be too wordy, but prescribe 16 milliliters is a perfectly good perfectly good answer to this problem. Similar shapes are shapes that are identical in their proportions, but they're different sizes. So here, for an example, we have these two quadrilaterals, four-sided shapes, and if we're told that they're similar, then their sides, I should say, all have to be in proportion to one another. So the length of this side compared to the bottom, the top to the bottom, must be the same for the bigger shape as well. So their common sides are in proportion to one another. So for this problem, let's go ahead and find B. So the sides must be in proportion to one another. So for the smaller shape here, the top to the bottom, so I'll go 17 millimeters over 22 millimeters, must be the same as the proportion of the top to the bottom of the larger shape. So that would be 51 millimeters over B. And now again, we have a rational expression that we can solve by whichever method we're comfortable solving it with. I'll show you another method here, especially when the variable is on the bottom. A common method is to cross multiply. So if I multiply this side by B and this side by B, that will cancel out the B's on the right-hand side. And I also multiply by 22, and we're going to cancel the 22's on the left-hand side, leaving me with B times 17 equals 51 times 22. I'm going to simplify the right-hand side. 51 times 22 in my calculator, I get 1,122, and I have 17 times B. Now I'm going to finish this problem by isolating B, dividing each side by 17. So I divide 1,122 by 17, and I get 66. So I can say B equals 66 millimeters. And don't forget to include units there, because this is a word problem, and B has an actual meaning, which is a length in this case. So make sure to give it the relevant units to explain that. Here's another common type of problem, which is a shadow problem. So we're told Tyler is 6 feet tall, and late one afternoon his shadow was 8 feet long. And at the same time, the shadow of a tree is 24 feet long. And we want to find the height of the tree using this information. So using our little diagram down here, we're told that Tyler is 6 feet tall and has an 8-foot shadow, and the tree is h tall and has a 24-foot shadow. And the way we're going to solve this is with similar shapes, this time using the little triangle that each shape creates. So Tyler creates a little triangle with the shadow and his height, and then the direction from the sun casting the shadow, and so does the larger tree. And because this angle is the same, because the sun casting the shadow creates this angle, and they're both standing upright, so they both have 90-degree angles, these are similar shapes. They have all these same angles in them, so they're all shaped the same, which means that they're all similar shapes. So to solve this problem, we can do it very similar to how we did the last problem, which is to set up, for these similar shapes, a ratio of their sides. So for Tyler, there's 6 feet, for his 6-foot tall self, there's 8 feet worth of shadow, and the proportion must be the same for the tree. So for the tree, which is h feet tall, we have a 24-foot shadow. Now from here, we would go 6 over 8 equals h over 24. And I'm going to go ahead and let you solve this equation because I've already shown you some similar equations to this. So you can go ahead and try solving this for yourself. and then you can check that you get the right answer at the end. So go ahead and try it and check to make sure that you get the answer of the height is equal to 18 feet. In this last example, I want to show you one where the solving is going to get a little bit harder than what we've seen so far. So in this example, we want to find the side length y in this triangle. So y goes from A to C, and then we know the distance past C to E is 10 centimeters, and we have these other lengths in the triangle. What's really important in this picture is to note these arrows that are on sides B, C, and DE. These arrows here tell us that those two sides are parallel to each other. And what that does is it tells us that all these angles in this triangle are equal, and that's important for knowing that these two triangles are similar to each other, that they share proportions of sides because all those angles are equal. So this smaller triangle here, which I'll outline in blue, must be proportional to this larger triangle, which I will outline in orange. So our larger triangle. So those two must be proportional to each other. So to find y, I have to use y and one other side. So I think I'll use y and the side length 12. So in the blue triangle, y over 12 is one proportion that I can write for one side to another. And that's got to be equal to the equivalent sides in the larger triangle. So the equivalent sides in the larger triangle for y, it's actually this whole side length here, which we don't know. So it goes from A all the way to E. The only way I can write this is by including y. The whole length is y plus 10. So in the top of my fraction, I'll have to write y plus 10. And this other side that corresponds with the 12 centimeter length goes from A to D, and it's 12 plus 8 centimeters in total, which is 20 centimeters. So the equation that I have to solve looks like y over 12 is equal to y plus 10 over 20. To solve this equation, we can go about it a bunch of different ways. Choose the way that makes the most sense to you, the one you're most comfortable with and can solve the most consistently. One method that I'll use right now to show you is by eliminating the denominators by multiplying by the lowest common multiple of 12 and 20, which is 60. So 12 and 20, they each have a multiple of 60. So I'm going to multiply each side by 60 to eliminate the denominator. And we've done that before in solving these rational expressions. Sometimes the lowest common multiple involves variables. In this case, it's just a number. So 60 over 12, that simplifies because 60 divided by 12, I should say, is equal to 5. So this simplifies to 5 times y. And then we have y plus 10. Remember, y plus 10 is all together in the numerator. And 60 over 20 simplifies. 60 divided by 20 is 3. So now my equation looks really nice. 5y is equal to, and I'll multiply the 3 in there, 3y plus 30. And now I can go about solving this equation. I'll bring the y's over to the left-hand side, so I have 2y equals 30. And then divide by 2, and I get y equals 15. And again, because all these lengths are in centimeters, I'm going to make sure that I write my centimeters to give that length the meaning that it needs. And so in this one, it's an example of a problem where you have to do a little bit more work after setting up that proportion to solve for your unknown.